right, E9. So some further examples for angles of elevation and depression. All right, here our question, and this question might look familiar. We've done this question actually before in one of our other examples, but the question here is, what is the angle of elevation from the man to the bird? So looking there, it's from the man. So we've got to start at the man and then look up to the bird. So if we can see in our diagram, from the man, you look out to the horizontal and then you go up to the bird. So you can see that down there is the angle that we are looking for. Right, now that we've identified our angle and all that information's on our triangle, let's go through and identify our side. So if I go through and look at that 30, well, that's the opposite side. 23 meters, well, that's my adjacent side. And what we end up having here is opposite over adjacent. So we have tan of theta is going to be the opposite side over the adjacent side. All right, well, tan of theta is going to be 30 over 23. Remembering that when we get to this stage, to solve for theta, we're going to press Shift tan on our calculator. So theta is going to be equal to that, that Shift tan on our calculator equals 52.5 degrees. So this man needs to look up at 52.5 degrees to see the bird. Example 3 here says, from the top of a vertical cliff. Now that's interesting because we can see our word from at the very beginning. So from the top of a cliff. Now the reason it says vertical is vertical just means it's going to meet whatever's at the bottom at right angles. So from the top of the cliff, that's our starting point. Andrew spots a boat out to sea. If the cliff is 42 meters above sea level and the boat is 90 meters away from the base of the cliff, find Andrew's angle of depression. So we were looking for the angle of depression to the boat. So from the top of the cliff, we're going out and then we're looking down to the boat. So here's a little bit of a diagram we've got going on there. So let's add this triangle in there to see what it looks like. So from Andrew at the top of the cliff, there's the boat, down to the boat. We know that the cliff is over there, and we were told that the cliff is 42 meters tall, and that when we come out to the boat, sorry, that's a dodgy triangle, is 90 meters away from the cliff. However, remember we were asked to find the angle of depression. So the angle of depression means I look out from the horizontal and then we look down. So what I need to do is we're actually looking for this angle in here. Okay, that angle's not in the triangle that I've got drawn at the moment. However, remember earlier we talked about that those we can make a right angle triangle, a rectangle. If I was to continue these dotted lines along, I can do this and make a rectangle. Now, if it's a rectangle, sorry, that's a really dodgy rectangle, that with my rectangle, what I know is that if it's 90 meters across the base, it's also 90 meters across the top. And if it's 42 meters high on one side, it's 42 meters high on the other side. So redrawing that so it's a bit neater, the triangle that I'm dealing with, that's fine there, with theta there, it's 90 meters across the top and 42 meters down the side. Now I can start identifying my information. Obviously, sorry guys, forgot my right angle is going to be in there. But so identifying information, 42 is the opposite side, 90 is the adjacent. I'm only dealing with opposite and adjacent. I've got tan again. So tan of theta is going to be the opposite over the adjacent. So tan of theta, substituting information in, is 42 over 90. theta is going to be, remember, that's where we press Shift 10 again. So it's 42 over 90. And let's see what our calculator produces there. Shift 10 of 42 over 90 equals, and we get an angle of depression of 25 degrees when we round it to the nearest value. Alright guys, I hope those extra examples help. Don't forget to complete those questions, and if there's time, those 10 quick questions.